Evaluate the limit as x approaches 0. So the first thing to do is just try and plug in a 0. So this will be 0, sine of 0 is 0. This will be 0, and tangent of 0 is 0. So that means that because this is of the form 0 divided by 0, we're allowed to use L'Hopital's rule. So then I like to put a little LH right here for when I'm using L'Hopital's rule. And then you take the derivative on the top, and that would be 1 minus cosine. Take the derivative on the bottom, that would be 1 minus the derivative of tangent is secant squared. And then try to plug in a 0 again. Well, cosine of 0 is 1, which means the top is 1 minus 1, that's 0. Secant squared, well, that equals 1 over cosine. So if you plug in a 0, this would be 1 over 1 squared. And then this would be 1 minus 1. It's still 0 divided by 0. So then we could do L'Hopital's rule again, because it's still of the form 0 divided by 0. And the derivative of this will be 0. The derivative of cosine is negative sine, and then that negative is going to cancel this negative, so it leaves just positive sine x on the top. The derivative here is 0, and the derivative of negative secant squared. So the negative stays there, and then you take the 2, bring it down, and multiply. So that was the power rule. Now take the derivative of secant, which is secant times tangent. So if you take the 0 and plug it in, that's going to be 0, and tangent of 0 is 0, so this is again 0 divided by 0. So we could try using L'Hopital's rule again, or we could try some trig identities and try to simplify this thing. I think I'm going to try that. So the top, that's just sine x, but the bottom, this is 1 over cosine, and because there's 2 of them, it's 1 over cosine squared, and then tangent is sine over cosine. And then one thing we could do is actually have these signs cancel, because you could multiply the bottom by 1 over sine x as long as you multiply the top by 1 over sine x. And then these will cancel, and these will cancel. And then this leaves 1 over cosine cubed. And because this in the numerator has a 1, and then you're dividing by 1 over, that means invert this fraction. So the negative 2 will stay there, but when you take this 1 over cosine cubed and invert it, it looks like this. And finally, plug in 0. Cosine of 0 is 1, which means that this is going to be 1 over negative 2, or in other words, negative 1/2. Now what I want to do is check my answer. So if you graph the original problem, and that was x minus sine x, put that in parentheses, divided by parentheses, x minus tangent x, and then it was the limit as x goes to 0, so make the window so that this goes from negative 1 to 1. And then I got the answer negative 1/2. So right now this is set from negative 2 to 2. I should be able to see if negative 1/2 is correct. And it looks correct. So it looks like the y value is the negative 1/2. I could even double check by taking a number that is close to 0, like a 0.001, plug it in, and it says you should be getting y equals -1/2. So then this gets a check mark.